Okay, I decided to do another example here. It's a longer example. I'm not sure I'll be able to finish it. I wouldn't be able to finish it in class, that's for sure. I might let's see, get some additional paper here in case I need some more. All right, so this is a problem out of Munson. Usually I've assigned this as homework before, so I'm kind of making a decision to make the video, and maybe I will make this a homework problem and see if people even notice that this was included as a homework problem. Or maybe I'll make it so it's a homework problem so that you have to work through it too. I don't know. So we'll see. Under certain circumstances, wind blowing past a rectangular speed sign can cause the sign to oscillate with a frequency of omega. Assume omega is a function of the sign width, the sign height, the wind velocity, the air density, and an elastic constant for the supporting pole. Now, the elastic constant K has the dimensions F times L, which seems strange to me. I would have thought that it would have been F divided by L. That's usually what we have for a spring constant, but they say to use FL. All right, so whatever. I guess we'll just do what they tell us. Develop a suitable set of pi terms for this problem. All right, so I've already written out the steps that you would do, that you would use for this, right? So we have 1, 2, 3, 4, 5, 6 variables, and we write out what the dimensions are here. Okay, so this is very similar to our first example. So base and height are both lengths. Velocity is L time per time. The density is M L cubed per L cubed, right? So like whatever kilograms per cubic meter. Here the K is FL. So we want to either use MLT or FLT. And I decided to go with MLT. So I want to convert that F into an MLT. And remember that F equals MA. So F equals ML T minus 2 right there, right? So in that case, we can replace F with mass times acceleration. So mass length, of course, there's a length already there, so that's length squared. So that's how that works out. So there's 3 things are represented here, M, L, and T. So there, R is 3, and therefore we have 6 minus 3 in terms of number of pi terms. We're going to have 3 pi terms. And they did not give us the repeating variables B, V, and rho. Okay, so why do we use these? Well, we don't want to be too redundant, and we want to represent every basic dimension. So this is the main one, so we can't choose that as a repeating term. We could either choose B or H, but not both of them, right? Because we don't want to be redundant. We want a variety. V looks pretty good because it's fairly simple. It introduces time in there, where if we'd already picked one of these, let's pick the width instead of the height. We could just replace it at the end if we had chosen the other one. But we already have L, but we don't have time yet. And then we come down to this one, and we see we could either pick density or we could pick this stiffness term, the constant that they're talking about. But we want to be as simple as possible, and we want to represent M. So it's probably going to be better to pick density than it is to be stiffness. You could probably make it work out with stiffness, but it might complicate your life because we have, remember that we're doing all of this to try to get exponents. So the more complicated we make it, the harder our little math is going to be in the end. We would get a totally different result if we picked K as a repeating term, by the way. So, but let's just see how this works out in this problem, right? So we have all 4 of those done. So let's go to step 5, and we will try this one out here. So I'll write out my pi 1 is going to be equal to omega, which is our main guy. It's our main variable up above. And now our repeating are going to be B, what order? I did it to this order. Okay, B to the A, and then we're going to have V to the B, and then I'm going to have rho to the C. Okay. And so underneath that, I am going to write out my time to the 1. And then this B is L to the A. V is going to be the LT minus 1 to the B. And then lastly, we're going to have M L to the negative 3 C. And we want to set that equal to M0 L0 T0. All right, so I like to have some columns here. And let's make 3 rows for the M and the L and the T. Now I'm going to neaten this. Oop, I need to make another column there. I'll neaten this up as best I can without going too crazy over it. Let's see. Get rid of some of these lines. My desk is so full of eraser shavings, it's not even funny. All right, so M, L, and T going across here. We have a negative 1. Nope, that's not true. Sorry, we have a 0. Starting off on the right foot. 0 and 0, no M's. 0, and then we're going to have a C. We can already see that C is going to be equal to 0. Sometimes actually, if I leave enough space, writing it over here to the side, it's kind of nice. C is equal to 0. Then let's go here. We're going to have a 0 here. We're going to have an A. We're going to have a B. And then we're going to have a negative 3C. And that's going to be equal to 0. But we already know that C is equal to 0. So we don't even have to write that, but we can write A plus B is equal to 0. So we know that A is equal to negative B. And then lastly, okay, here's where we have a number finally. Negative 1, nothing here. We have a negative B, and then nothing here. So what we find is that B is equal to negative 1. And therefore, A is equal to positive 1. And so our first pi term is, let's do it this way. So people like this, where we have omega B, which is the base to the 1. And then we have V raised to the negative 1. So what we have is omega B over V. And that kind of just makes sense. So this radians per second times length. So that's going to be a speed over this speed right here, right? So we already kind of just did step 7 for this, just to double check. We know that's dimensionless. Let's go on to step 6, right? So that was for the first term. Now we have to do it for the other non-repeating terms. One of them I don't think we even need to do, right? I think we can skip doing H, right? Because that's a non-repeating term, but we know that it's just going to be H over B, right? So we can go that pi over 2 is going to be H over B. But here's one that's going to be a little bit more challenging. We didn't have K, so we really need to do that. So let's call that pi 3. All right, so that pi 3 is going to be equal to K times B to the A times V to the B and rho to the C. All right, so let's write that underneath it. We're going to say K. We already were told up above we did M L2 T minus 2. All right, kind of didn't fit that in there. Let me I should have forecasted a little bit better. Right. ML2 T minus 2. Didn't do any better. Okay. And that's going to be, what is it, L to the A. And then LT minus 1 to the B. And then lastly, ML minus 3 right there. Let's see if we could do something here with my columns. Guesstimate the lengths I have to go to. It's going to be equal to M0, L0, T0. And I'm going to pick this out a little bit better. 1, 2, and 3. It's like watching paint dry, right? Up here, I think I need another column here, and let's close it off right there. Let's neaten it up a little bit. Here we go. I guess I'll move this down. There we go. I meant to write it here by observation. By observation, I guess that's right. All right. M, L, and T. And so starting out here, we're going to have 1, 0, 0, and then here is just going to be C. It's equal to 0. Therefore, you could see that 1 plus C equals 0. Therefore, C is equal to -1. We're starting off really well. So we have 2 here, and then we're going to have an A here, and a B, and a -3C equals 0, right? So there's a little bit to unpack here. So we say it's 2 plus A plus B minus 3C equals 1. Right, so we already have that that's going to be -1, so that's actually going to be a +4. I think that's correct, right? No, +3. Jeez, you're a big dummy. And that should have been equal to 0. Wow. Okay, I need to go eat lunch. That's what it is. That's my excuse. Lastly, let's go for the time. -2. Right here is 0. Right here is going to be -b and 0 right there, right? Equaling 0. Therefore, we're going to have a -2 minus b equals 0. So b is going to be equal to a -2. Is that right? If we put this back in, right, so if we put in this guy right there, and we put in this guy, what we're going to find is that we're going to have a is equal to -3. So our last pi term, pi 3, is going to be k times b raised to the -2 times velocity raised, whoops, gotta be careful. This b was raised to the a, right? So it's a -3. V raised to the b, and that's -2. And then density is raised to the -1. So our third pi term I guess I'll write it underneath it here. I'm just barely running out of room. It's going to be, it's all in the denominator, so it's going to be this k divided by b cubed v squared and rho. And we should really check this in 7 for the dimensionality. This is the one we should check, right? So let's write this out. That's going to be ML2T minus 2 divided by L cubed, and go L squared T minus 2, right? Because that got squared. And then M L minus 3. I think it's going to help to write these out again. But now moving everything up here. There you go. And so we see, we'll see the masses cancel out. The time cancels out. We have negative 3, 2. Oh, there's a 2 right there. That 2 cancels out. And I think, yes. So this one cancels out. We already kind of, from observation, already kind of said this one up there. So in due diligence, we've done correctly. So the last part, the step 8, I'm going to use the margin right here. Why bother making these little margins if you're not going to use them? But the big idea was that omega b over v is equal to a function of, or is related to, the variables h over b and k over b cubed v squared rho. So there you go. We could run out some type of experiment, some kind of model, verify, or see what this relationship is for these parameters, to try to maybe, knowing a particular maximum velocity, we want to try to stay away, so we get away from the natural frequency of this thing, so that we don't cause resonance. So there you go. That's like 16 minutes. It wasn't too terribly bad, but I was thinking about maybe including this as a homework problem and seeing if anybody would watch the video. Be interesting experiment to do. Experimentation. Thank you, and we will talk again soon.